Hello everyone, this is Mrs. Lindsay Pereira. Today we're going to talk about topic number 4, which is simply simplifying rational expressions. Okay, so let's talk about what is a rational number / expression. And a rational expression is really no more than a fraction in which the numerator and denominator are polynomials. And occasionally they'll say the word ratio instead of fraction. So here are some examples of them. It can be something as simple as x over 3. It could be a little bit more complicated, where you have two binomials like x plus 1 over 2x minus 3. Or it can even be much more complicated than that. Plus 2x minus 1 over 5x squared minus 3x plus 4. So again, from simple to complex, but again, really it's a fraction in which your numerator and denominator are polynomials. Okay, so I would like you to pause the video here. You have A, B, C, and D. Talked about these a little bit when we were solving equations here. Don't use a calculator, okay? I know you probably have one sitting right there, but don't use a calculator. Try to do these by hand. Push play when you're done, and we can kind of go through that whole process. Again, just remember, A and B, you're adding, subtracting. You need like denominators for A and B, because you're subtracting and you're adding. Multiply in C, multiply numerator times numerator, denominator times denominator. Think about what you have to do with division. Okay, we'll talk through those, but try these without a calculator. Push play when you're ready to check your answers. Okay, so again, the first ones you got to get like denominators. So I have multiplied top and bottom here by 7, top and bottom by 3 to get the like denominators of 21. Then you can add your numerators. Same idea over here with B. Let's circle my answer here. And then multiplied numerators got 8, multiplied denominators got 15. They don't reduce. D, I want to take a little moment to talk about that one. How do you divide? Well, hopefully you remember that you change it into multiplying by the reciprocal. And the reciprocal is switching the numerator and denominator. Couple different routes you can go here. You can go ahead and just multiply the numerators together, multiply the denominators, then reduce. I chose to reduce. Okay, so I reduced 5 over 2. Now again, I can multiply numerators, I can multiply denominators. I'd get 5 over 10, which is a half. But I could also do this, 1/5 times 5 over 2. Cross cancel. 5s go into each other one time, so now I have 1 times 1, which gives me 1. 1 times 2, which gives me a half. So again, either approach should still give me the answer of a half there. Okay? And again, I know you can plug these in your calculator, but it's a good idea to refresh yourself with this. We will go back and forth between using calculator and non-calculator. Okay, so let's try a few simplifying here when we actually use some variables. So same sort of idea as our 4 problems that we just did, but I replaced the numbers with variables, A, B, C, and D. Okay, so 1 and 3 are like A and B. I need to get like denominators. Well, if one denominator is B, one denominator is D, the like denominator would be BD. I'm going to go ahead and just write those down. Well, what do I have to multiply B by to get BD? Well, I'm missing the D. So I multiply top and bottom by D, which gives me AD in the numerator and BD in the denominator. Same idea here. What do I have to multiply D by in order to get BD? Well, I got to multiply this by B and this by B. Not sure why this is here. Let me try to get rid of that. Okay, so C times B is going to give me CB. B times D gives me BD. Doesn't matter if I write BD or DB, it's the same thing. like denominator, so now I can add my numerators. Well, I can't actually physically add those. Those are not like terms. So my denominator is AD plus CB over BD. Okay. We're going to do 2 and 4 in just a moment, but I would like you to try 3 on your own. It's very, very similar to number 1 that we just did, but now we're subtracting. So go ahead, pause the video, try that one on your own, push play when you're ready to resume. Okay, so hopefully you realize it's the exact same answer. However, we are just simply subtracting now instead of adding. Okay, so multiplying. So again, numerator times numerator, so A times C. Denominator times denominator, BD. That is it. That is a B right there. I don't know if I made that worse or better. Let me erase that. That's a B. Okay. However, division turns into multiplying by the reciprocal. Now I follow the exact same properties, numerator times denominator, so AD over B times C, denominator times denominator. Okay. All right, so let's take a look at our next page here, simplifying still. Now we have a few different things here. So we're actually going to kind of jump ahead a little bit, and we're going to have some factoring going on here. Okay. That's going to come into play into 5 and 7. So I'm going to do 5 and 7 first, and then I'll do 6 and 8 after that. Okay, so if you look simply at the numerator here, 5a plus 10a to the third, I see 5 goes into both 5 and 10, and I can take an a out. So I'm going to factor out, it's called taking out the GCF, 5a from both of those. So 5a divided by 5a would give me 1. 10a cubed divided by 5a would give me 2a squared left over. So again, think about this. If you're not quite sure, check it. If I distributed, did I get the original problem? And I would. Okay. So now I can cancel those 5a's, and I'm simply left with 1 plus 2a squared. Same sort of idea for number 7, but with 7, I'm looking at the denominator here. Okay, what goes both into 12n squared and 9n? Well, hopefully you see that as 3 and 1n. And again, now I'm not changing my denominator. It's just going to remain the same. So divide. 12n squared divided by 3n, 4n. 3n divided by 3n, I'm sorry, 9n divided by 3n is minus 3. So again, I can cancel the 3n's. Now remember, this is in the denominator, so I have to put a placeholder here. 3 divided by 3 is 1. N divided by n is 1. So I should get that to be 1 in the numerator, 4n minus 3. Okay. Okay, so hopefully you see some similarities here looking at 6 and 8. We want to add them. Okay. Let's talk about 6. So we need like denominators. 3 and 7 both go into 21. So I'm going to multiply top and bottom by 7 there. Get 7 over 21. Again, I need 21 in the denominator. So 7 times 3 is 21. So I get 12n over 21. So my denominator is now 21. If I add the numerator, not like terms. So it's going to be a polynomial in the numerator. So 7 plus 12n. Okay. I'd like you to try 8. Okay, pause the video. Push play when you're ready to resume. And again, I know you can put this one in your calculator, but please try to do it without using your calculator. All right. So a little different because of the negative here. A couple different ways to do it. I chose to make it a positive 55. So I multiplied the second fraction by negative 11 in the top and the bottom. So I made this to be a positive 55. Because if I have one as positive 55 and one as negative 55, I got to do something with that negative sign. Okay, so then I do 45 minus 33, which gives me 12 over 55. Okay, so let's try 9. All right, a little bit different with this one. So if you recall how I talked about canceling, I'm going to go all the way back to this first page here. How you can cancel. You can cancel up and down, like reducing here. That's exactly what I did here. Canceled and got 5 over 2 and simplify it. Or you can cancel diagonally. That's the same idea I'm going to do here. I can cancel up and down with both fractions. I can also cancel diagonally. So let's just start with the x, just because it's alphabetical. I see that I have 4 of them here. I can cancel those out. If I have 4 in the numerator that I cancel out, I'm canceling 4 of these out here. And again, that was originally a 5. If I cancel 4 of them out, that means I have 1 left over in the denominator. Okay. Now if I look at the y's, again, I'm just literally going alphabetical here. I see I have 2 y's that can cancel out here. I have a y here and a y here. I can cancel in a couple different directions. If I just literally cancel here, that means I'm going to have 1 y left over. So I have y times y, so that gives me y squared in the numerator. Z's, I see I have 2 in the numerator, I can cancel. And then that means I'd have 5 of them left, because again, I'm taking those out of the denominator. So I have y squared. Let me just go ahead and clean that up just a little bit. Y squared over x times e to the 5th in the denominator. Okay. Number 10. Again, another problem very similar to 6 and 8. So I'd like you to, again, pause the video for this. Excuse me, and try this one. Check your answer when you are ready to, when you're done with the problem and ready to check. Okay, try to get the same denominators. So y and 3, so that would be 3y. So I had to multiply this top and bottom by 3. Top and bottom here by y. So I got 9x over 3y minus 2y over 3y. So denominators are going to be the same. 3y will be the denominator. Again, not like terms. So I simply have a binomial or a polynomial in the numerator. 9x minus 2y. Okay. All right, so this concludes our notes on topic number 4, simplifying rationals. There is a little homework assignment that you'll have to get off of Schoology. Remember to look in the daily folder, print that out. That is what you'll finish and upload. Prior to that, though, there's a short little quizzes. If you could log on and take that as well. It's, again, fairly short. But do that and then do the homework and upload that to Schoology for your homework this evening.